webinar on simulation of battery. So first of all, we'll talk about the battery. So we know that the battery isn't very, yeah, good evening everyone. So first of all, we know that the battery is a very crucial part of an electric vehicle. So the safety as well as the exact calculation of the battery is very much important, so that battery can be give us the proper range, and also it performs their function under the safe operating conditions. So we know that we have the battery of different chemistries, either lead acid, NMC, lithium ion. So lithium ion batteries are the most uh, promising into the EV industries because of high power density, and also their life cycles are very much high as compared to other chemistry of the batteries. So now we know that what. So today agenda of these sessions will be about the battery modeling. So how the battery modeling is done, what are the different approaches. So I will be talking like the basic, like in battery modeling, what we do, we convert them into the equivalent circuit. What are the different components which are present into the equivalent circuit of the battery, and what are the uses of that. And also after that, we'll be talking about the SOC and the OCV relation. So let me talk about the first SOC. So SOC means state of charge. So it is an important battery terminology, which means that like we have our cell phones. So in our cell phones, we can see there are the percentage indicating. So that is the SOC, like how much energy is being remaining. So let's suppose if my mobile phone has the 72% showing. So it means that the 70% of the total energy is being remaining, and rest 28% is being exhausted or being used. So this is SOC. Then it is the second concept is here the OCV, which is open circuit voltage. Now open circuit voltage, it means that you can understand from the word like the OCV, open circuit voltage, which means that when a battery is not connected with any load, any type of load. So if we if we connect the positive terminal as well as the negative terminal of that battery with a multimeter and check the voltage, then you can see that the OCV or the whatever the voltage is there, so it will be showing there. So this is the agenda, and after that, at last, we'll be do a MATLAB simulation. So we'll be do some hands-on MATLAB, in which we'll be designing a battery model, including taking the internal resistance, like during charging and discharging the battery internal resistance, what are the effect of the battery internal resistance. So we'll be talk more about that, and also we'll be talking about the different equations which are used for knowing the SOC of the battery and also the terminal voltage. So any questions till here? Like I think your motive is clear about the today's session. Any doubt? Is it clear? Okay. So first one here is the battery modeling. So I will be talking about the battery modeling. So main purpose of the battery, or you can say the first step in designing a battery management system. So battery management system are the heart of the battery, you can say. So what they do, they track the battery voltage of each number of cells. Like when we see a battery pack, so there are n number of cells connected in series or rather parallel combinations. So to ensure that each and every battery pack are performing under the safe operating conditions, like there is no exceeding of temperature or the voltage level. So for that we use a battery management system. So the first step in designing a battery management system is to develop a fidelity battery model. Like I already told that we have to design a battery model. For that, according to that battery model, we design a BMS. So BMS, so from that battery model, what we do the estimation, like the SOC estimation, SOH state of health estimation, and other estimation, including the batteries as well as the accurate battery current also. So the estimation is being done through this battery model only. So for the battery modeling purpose, the mathematical, like there are mathematical equations also present into the battery. So depending upon that mathematical equations, we design the battery or cells. So the purpose of this battery model, like we design a battery model, so it will be showing or it will be replicating the exact behavior of the cell, like why we have seen into the like some of the electrical engineering students or mechanical. So in transformer or the induction motor, so what we first derive the equivalent, draw the equivalent circuit, like we take some approximation and design and derive the equivalent circuit to make our study more precisely or more accurate. So same thing here. The purpose of designing a battery equivalent circuit is to do the estimation or the study of the critical parameters of the battery precisely. So this is how we can see the battery, and this is a cell, and after that we develop its battery model. So, so that was about the battery model. Now we'll be talking about the OCB. So I already told that the open circuit voltage. So see here, you can see that this is a battery pack, and we have here the positive terminal as well as the negative terminal, and a negative and a multimeter is being used here. So what we do into the multimeter, we connect the positive terminal as well as the negative terminal, and we check the voltage. So there is no load connected to this battery pack, and whatever the voltage will be there, so it will be replicated into this multimeter. So that is the open circuit voltage. So whatever the voltage that will be showing upon that, so that is the only open circuit voltage. Not talking about the closed circuit voltage. So when we connect any load, so into the load it will be either a resistive RL load, LC load, or any inductive or capacitive or RLC load. So any load is connected. So after that, when we measure the potential, like load is connected, and we going to check the voltage, output voltage of that battery pack. So what is that? That is the only closed circuit voltage. So this is the basic difference between the open circuit voltage as well as the battery closed circuit voltage. Now, talking about the OCB and the SOC relation. So it is, so here you can see here the curve, like the SOC and the battery voltage. So this is the lower cutoff voltage, and this is the higher cutoff voltage. Let's suppose this battery has the higher cutoff voltage of 4.3 volt, and this one is for 2.2 volt. So during charging as well as the discharging, so this one is about the charging. So when we connect the power source to the battery pack, what will happen? There will be increase into the battery percentage or the SOC, and there will be increase in the battery level also. So you can see here, when we start charging, like from 0% till 100%, so you can see the voltage level of this battery pack will be reaching near to 4.3 volts. And most of the time, so let's so standard it will be 3.7 here. Okay, so 3.7, it will be the nominal voltage, like the most of the time the battery will be trying to be on its 3.7 volts. So this is the nominal voltage, the upper voltage, and the lower voltage also. So this one can be the lower cutoff voltage, and this one will be the higher upper cutoff voltage. So if a battery exceeds this voltage, then the battery can go, battery may get damaged, or the potential of this battery will be changed, and the battery may blast or explode. And if the battery goes beyond this lower cutoff voltage, then what will happen? The battery will be going into the deep discharging. So either from the deep discharging, either the battery needed to be replaced or to be charged with a high value of current. So we should always avoid this lower cutoff as well as the higher cutoff. We should always remain, the battery voltage should be remain in between these two. So during charging, you can see the path of the voltage is this one, and during discharging, you can see the path, like it is taking some another voltage. Okay, so when we take, let's suppose it is 10%, 20%, 30, 40, 50, 60, 70, 80, 90, and 100 here. So when we drag a line here, so you can see during charging, the voltage measured at 10% was something else. But during discharging, when the battery reaches a 10%, then the voltage will be different. And at 20%, the same thing we can observe that the charging voltage during 20% as well as the 30, during discharging, the voltage level are different. So this is due to the hysteresis. So hysteresis is nothing but the difference into the curve, like during charging as well as the discharging, there is some voltage, so there is some losses. So this is this area, like you can say this area, this is nothing but only the hysteresis loss, because during charging and discharging there is a little bit difference between the path of the charging as well as the discharging voltage. So this is how the battery charge as well as discharge and during charging at different SOC. Okay, so I think you are clear right now. Anyone have any doubt, you can ask. Like till here, I think everything is clear about related to SOC, the battery voltage, like whatever the things I have said. Okay. So simply
Yes, sir,
what
clear
we
now.
do, we take an approximation and we do the averaging. Like during charging and discharging, we take averaging of their particular voltage. Okay, and after that averaging, the charging and the discharging SOC OCV relation. So you can see here like the 10%, 20, 40, 60, 80 and 100. So after averaging, we found a data which you can see onto the screen. So that is taken into the standard. So let's suppose it is 20% and at 20%, the voltage is near about 3.25, and for 40 at 40%, the voltage is near about 3.5, and 60 near about 3.7 and 3.5. So this is the nominal voltage. Like the most of the time, the batteries remains at this potential only, and this is the upper cutoff. So this means that beyond this value, the battery voltage should not go, and this is the lower cutoff. Okay. So, so this is how the SOC as well as the OCV relation of a battery, or you can say that the different voltage at different SOC, what is the voltage C observed. Now, coming to the battery modeling approaches, so this is the equivalent circuit. So here you can see this is the source, or you can say the SOC, OCV here, and this is the internal resistance, and this is the RC combinations. So inside the battery, I already told there is a hysteresis loss, and also that there are some losses which is known as the polarization loss. So in polarization losses, what happens? So let's suppose when a battery is not connected to any load, at that time the voltage is at this level. Let's suppose 4 volt. So whenever we connect a load, there will be a dip into the battery voltage, and once and this dip is very less, like near about milliseconds. In milliseconds or few seconds only, there will be a dip, and after that, battery will be again getting its stable voltage. So it is observed that when there is no load, the battery voltage was 4, and after that the load is connected, then there is a little bit dip into the voltage. Let's suppose it is 3.8. So this is nothing but the polarization here. So when the load is connected, so due to the polarizing effect to the battery observed, there is a dip into the battery voltage. And then we have the internal resistance. So internal resistance is a phenomenon which is present into the battery, like due to the other components present into the battery, whether they are electrode, anode, cathode, separator. So because of that, some resistance is formed which which resists the flow of electron inside the battery. So this is how a battery equivalent circuit cell model look like. Okay. Now coming to the simulation into the battery model. So we'll be moving towards the main thing of this webinar, that is about the simulation model. So I will be doing a mathematical simulation onto the MATLAB. So we are going to use this equation. So this is the VT, which is the terminal voltage, and this is the OCV. So OCV is nothing. Here the open circuit voltage, and here it is the data I will be taking from a data sheet of the battery. So at different SOC, the OCB is calculated into that Excel sheet, and also the resistance, like during charging or discharging, will also be C. And this is the SOC equation. So this is the battery terminal voltage equation. So we will be using this equation as well as this equation, and we will do the mathematical modeling of the battery. Yeah. Now coming to the SOC. So this is the SOC, and this is the SOC initial, and this is the negative and 1 by Cn, which is the battery pack capacity, the AH rating of the battery. This is the AH rating of the battery, and this is the current. So this current is nothing but how the current is being withdrawn from the battery or taken out or given inside the battery. So from this equation, so I already told that SOC is nothing but the battery percentage, and this is the SOC, like the initial SOC, like at any instant. Let's suppose at any instant my SOC is 60%. Okay, let's suppose 60% is here. So what will happen? Like if I want to discharge the battery, so what should happen? This SOC should decrease or increase. Like the value, this value, this SOC should go above or sorry, it goes more than 60 or less than 60 when I am discharging the battery. Can anyone tell me? So can anyone tell me? So my question, I'm repeating the same question. So my initial, like at present, my SOC of the battery pack is 60%. Okay. And I am discharging my battery, like I have connected a load to my battery. So what should be the value of this SOC? Should it decrease from the 60 or increase from the 60 value?
Decrease from the 60 value.
Decrease, yeah, decrease.
Decrease.
So, yeah, it should decrease. So what does it mean? What should be the value of current here? Negative or positive? Yes, I'm saying that what should be the value of current?
It will be negative.
Negative. Are you sure?
Positive.
Yeah, it should be positive. So my thing is, I want to clear is that, so whenever the battery is connected to a load, the current from the battery, like we are taking out the battery current, so that configuration of current is positive, because positive here and it is negative, so it will be negative, so it will be decreasing. So this term will be decreasing the SOC. So now when I connect a load, like I am feeding the current inside the battery pack, so that during that time, this value of current should be negative here. Okay. So once this value is negative, it means that negative and negative will make positive and the SOC of the battery will increase. So during charging, the current of the battery is negative, and during discharging, the current of the sign conversion of the battery is positive. So this was the basic equation which we have talked about the battery. Now we will be moving towards the MATLAB section. Okay. So let me open the MATLAB. So this is an Excel sheet. So upon which I will be showing you the data. So
Sir, your voice is not clear.
No, wait a minute. Is it clear now?
No, sir.
Wait a minute. So can you confirm, is my voice clear now?
Yes, sir.
Yeah. So earlier it was clear or no? So you understand everything? So from any doubt from the previous portion, like whatever I have shown or explained, so is that clear, na? So this is an Excel sheet which is representing the SOC, the OCV, the charge resistance, and the discharge resistance. So you can see here the SOC is from 0 to 0.0123, so on. You can see here the 0.1 is the 10%, and 0.2 is a 20. Similar on 0.4 40, 0.6 it is 60, and 0.8 it is 80, and 0 and one is here the 100%. So this is the SOC. So and from the data, like the from the charge and data sheet of the battery, we have seen that at different SOC we observed that the battery voltage is different. So at 100% or at 100% the voltage is 4.3, 99% it is 4.19, and 90% it is 4.02. Talking about the 80% it is 4.01. So we can see here onto the screen that the SOC as well as the OCV at different SOC is changing. Okay. Then at similar at same SOC, at different SOC, we have the charge resistance in value into the ohms, and SOC and discharge resistance at different SOC. So onto the screen, this data Excel sheet is being shown. Now what we will be doing will be we will be using this Excel sheet to develop our model into the MATLAB. So this is my MATLAB screen here. So here what we will be doing will be, first of all, we'll be selecting the battery parameters. So I already selected the folders, like whatever the folders, like I have the Excel sheet onto which I have to use that Excel sheet data and incorporate into the MATLAB workspace. So what I have done, I have selected the folder. So from here we can select the folder. Okay, so similar way in desktop I have saved the today webinar folder and I have just selected here. So you can see the battery parameter data is being configured. Now for now what I will be doing, I will be writing few codes. So name of this file, let me show you one thing. So the battery file name is battery parameter, battery underscore. So I have to remember this file name. Now I will be writing few codes onto the MATLAB editor. So here how we will be writing. So first of all, I will write data. So I will be writing here battery data, and it which will be, I am creating a variable and I will be writing XLS XLS read, and I will be selecting here that file name which was battery parameter. So the caps lock and everything should be same. Okay. So I will be putting here the underscore and I will be running this. So before that, I have to save this file. So I will be writing and saving this file as yeah. So when I run it, so after that, when we come to this screen, so here it is showing some error. So we'll see whether we have written the name correctly or not. So here it is the parameters. Okay, so let me add my parameters. Yeah. So you can see here that Excel sheet data has been coming into this MATLAB. Okay, so we have here that Excel sheet onto this MATLAB workspace. So you can there see that SOC, the OCV data, this one was the charge resistance and this one was the discharge resistance. So I will now, we have the Excel sheet onto our MATLAB workspace. Now what I will be doing, I will be writing a code to separately select all the data. So for that this one is my first column, this is my second column, and this one is my third, and this one is my fourth column. So for that, what I will be doing, I will be writing the code, which is, and that code I will be writing. The first one is the SOC, and this one is the battery data. Okay, so I will be writing here battery data, and I will be selecting here this value, and I will be selecting here the column. So this is how we write codes into this MATLAB. Then I will be using the SOC, which was the second column. So I am taking out each and every Excel column and to separately into the MATLAB workspace, because I will be using each and every column into the MATLAB simulator. Okay, so I will be run onto this. So here we can see the each and every section has been coming into this MATLAB workspace separately. Now the main thing here, what we have to do now, I have to open the Simulink onto which we'll be doing the simulation part. So I have shown you the equations. So that two equation I will be trying to build upon the MATLAB. So what were my equations? So these are my equations. So this is the VT which is equal to OCV, the function of OCV, and I into R. So, and this is the integration of IT, and this Pn here is the capacity AH rating of the battery, and SOC it is the initial SOC, and this is the present SOC. So let me open this MATLAB Simulink. Okay. So first of all, let me save this as battery model. Yeah. So I save this model. So here I bring the equation. Okay. So from first of all, I will be developing this equation. So here we can see that this is SOC and this one is the and this one is 1 by minus. So first of all, And here I have the integrator. So you can see here integration. So first of all, I will call for an integrator. So this is the integration block here, and the integration is done for this block, which is the current. So let me in this current. Yeah, this one I have this current. So I will be using a constant block here. So on this constant block, so this constant block is integrated here. Okay. So this is my I. So I will be putting here the value I here, which is let's suppose I have given a variable name here. So it is showing red because I didn't define any variable value of this value I. So once I complete my model, I will be putting the value of I into the MATLAB workspace. Now, after that, what I have to do? I have to multiply this integrator with this, yeah, with this 1 by Cn. So let me call for a gain block, which is 1 divided by 1 Cn. So I am creating a variable and it is as Cn. So Cn is here. Now this one will be giving my SOC. Okay. So I will be connecting a scope. Scope is used for viewing the colors. Then now we have here the R as well as the SOC value. Okay. So internal resistance I want. So let's suppose I am talking here about the charging or discharging. So first of all, we'll be taking about we'll be taking this lookup table of discharging. So we'll be call for lookup table. Lookup table. So what is the function of this lookup table? So we have the data, Excel data, or the series of data point and series of data point into the MATLAB workspace. Now I want to use that data from the MATLAB workspace to the MATLAB simulink. So for that I am using here this lookup table. So the table data and the breakpoint, the one data. So this breakpoint is nothing but the x-axis. So at x-axis I am putting the value SOC, and here the table data which will be of our discharge. Okay, so the name which I have given into here now. Here, same name should be given here also. Otherwise, the MATLAB will not fetch the value from the workspace. Okay, now I will be putting here apply. So once I put the apply, so you can see here the graph has been changed. So we'll observe that what is the reason of change. Now, second thing, we'll be calling, this one was my R value, and now we'll be calling the SOC value. So let's suppose same thing we have to do, like the SOC will be at x-axis and OCB at the y-axis. So same function we'll be calling, which is lookup table. Sorry, this one. This one will be the OCV. This will be the SOC. So you can see here the graph is changed. So we'll observe it. So let me open the Excel sheet. So if I do select all this, let's see, and I put the stop. So you can see here, I have given plotted the curve. The same thing is being showing here also. Okay, the same thing is being showing here. Similarly, if I select this whole block and this, I use discharge. If I do select all this block now, So SOC will be downwards, and but this discharge resistance will also be present here. So this part is representing. So this blue line is the open cell OCV, and the lower part is the resistance, which is SOC. And but here you can see orange and the green part. So this is representing us the discharge as well as the charge resistance. So this is in Excel how we plot the curve. Now what we'll be doing, we have taken all the data, both the data. Now will be according to the equation. So VT is equal to OCV minus. So we'll call for some block here. Okay, so this is nice. This one will be connected here. So this is my OCB. My OCB is connected to this one is I into R. So I here, this is this one. And this one is the resistance. Okay, so R, this one is my R value, and this one is my I value. So I into R, and then it is being subtracted. So here at the lower part, I need a subtraction here. Okay, so I will be this value here, and then my OCV value. So OCV value of mine, which is the function of SOC, and also the SOC will be here. So this R is the function of SOC. So the output of this one will be my SOC itself. Now I will be calling for a product plot. So in product plot, what we can see that the value of R and the value of I, it is connected to this. Okay. This part. Now we'll be using our scope block here, and we'll be using this value to see. So this is my complete model. And like this equation, we have seen here the mathematical equation. So I have used this mathematical equation to show the values here itself. So these are my the value. So at this output, I will be getting dt here, and at this output, I will be getting SOC. So let's talk about this variable I and Cn. So coming to this MATLAB editor block, so I will be giving the value directly here, the I value as well as the capital Cn value here. So from here only itself, the value will be fetched to this MATLAB workspace, and then we can see. So let's suppose I will be taking the value of this battery pack. It is 10 Ah. Okay, 10 Ah, which means that 10 ampere per hour. So 10 ampere hour, but I will in MATLAB simulating the simulation part. So this will is the stop time, it is in second. Okay, so for running, I will be running this software for 1 hour, which is 3600 second. Okay, and also same here, I have to convert this 10 Ah into hour into second. So for that, I will be multiplying this 10 with 3600. Okay, and my one and my current is here is, let's suppose it is 10. Or I will be running this. Sorry, sorry. Okay. I have to change the name. So now here. So when I run the block, the error which was showing here, that was red colored shadow, it has been removed because I have fetched the value of I and Cn here. Now we'll be seeing the SOC as well as the VT. So when we open this block, so we can see here the curve. So I showed you that how the value is being changed, like from 1 volt to 4.4. So I done this simulation for 3600 seconds, which is near about 1 hour. And in 1 hour, you can see the battery is being charged for 100% because the AH rating of the battery pack is 10 AH only, which means if we give the 10 ampere current for this battery for 1 hour, then the battery will be charged 100%. Okay. And when we discharge and when we change the value of current, let's suppose the value of current here I kept it, let's change to reduce to 5%. 5. Now I run it. Now I again will see. So you can see here. So now the till 50%, this much of voltage is present here. It is not going above that. And also when we see the SOC, so it reaches to only 0.5, which is the 50%. So when I reduce the current value, and that means I reduce the value of 5 ampere, value of current to 5 ampere, and the battery pack capacity is 10 ampere hour. So in 1 hour, the battery will be 50% charge only. But when we increase the volt current time, let's suppose 7200 for 2 hours, then after that we'll see what is the value of what is the SOC. So in 2 hour, this this battery will be 100% charged. So you can see here from 0 to 1, the battery percentage has reached. So this is how we do the modification and we do the analysis of the battery. And if we decrease, let's suppose increase the value to 20. And behind the simulation form. So if I increase the value of current to 20%, so it will be fully charged in 1800 seconds, half of 46. Or suppose in 1800 seconds, we can see here the value of SOC is reached towards the 100%. So this is how we can analyze the battery. If we change the value, if we increase or decrease the value of current, how the value can be value of current or the how much time it is taking to fully charge or fully discharge the battery pack. So this is how we can, if we want to use the discharging, so what we have to do, we have to do nothing but we have to reverse the current. And like I have to put here the negative value of current, and then we can see the change in value of the current. So now we can do a number of things like for our understanding, for our practice, and to get a brief knowledge about the battery pack. We can perform different calculations as well as the different modification into this patterns. So this was the MATLAB modeling of this battery pack. So any questions till here? Can we receive the I'm asking like if you have questions from the related topic. So these questions related to certificates. So you will be answered just after the session. So that was all from my side. So if you have any doubt, you can ask. We can discuss here right now. I hope you like the session. No doubts. Okay, thank you. Thank you.
Hello everyone. Am I audible to you? Yeah, so guys, I hope you guys like the session, and if you guys are having any query, you can ask it right now. If anyone has any query, you can ask it. Yeah, feedback link will be shared in a while in the chat box itself. Okay, so thank you everyone for watching this. Yeah. Around, you want to ask anything? You can unmute yourself and you can ask. Okay, thank you. Thank you everyone for watching the session. I hope you guys like the session. So related to these webinars, we are having courses that are totally designed on electric vehicle. And we have different type of courses available that is on battery pack designing, BMS and BTMS as well. So I will play a short video where you will get the complete understanding what are the products we are having and how it is helpful for you and what are the courses are available with us. So please watch the video.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling, and upskilling, at engineering institutes across India, we are setting up a state of art facility, Center of Excellence for e mobility research and skill based education, which is equipped with research and project based learning oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation, and product design and development. It is a combination of 6 labs, including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
So I hope you everyone have gone through the product that we are having. So we are offering a course to wide domain of the people like the students or the working professional, the dropouts or the working professionals as well. So we have multiple courses which we are offering with different type of placement opportunities. We are having multiple placement opportunities in the OEMs, automobile industries, and other industries. And we are also offering a courses that are in the blended mode, the online plus the offline modes. So you can join our courses where you will be having a hands-on training as well. In our center of excellence, we are having 14 center of excellence in all over India. In every part of the India, we are having the centers. So you can go and visit and have the hands-on training over there as well. And we are also offering a pay after placement with our courses. So once you are getting placed, then after that only you have to pay raise the course fees. Okay. So if you guys are interested in any of our program, you can join and you can fill up the inquiry form that is available in a chat box. Or I will request Hardik to share the QR code so that you can scan and you can fill up the inquiry form as well. And if anybody wants to establish the center of excellence at their college or the institute, they can send us the query in the same form. So we will help you get the center of excellence established at their institute, at your institute and the university. And student, this link is not to download the certificate. You can, if you guys are interested in joining the course on electric vehicle, then only fill this form. Otherwise, you will be getting an email on your email for downloading the certificates with the steps what you have to do to download the certificate. So once the webinar is completed, then you will be getting the email as well for the same.